Hey folks, I hope when you read this, it made some sense. Sometimes the math book is tough to understand. And so what they're saying here is that we have a differential equation. What the heck? We have an equation because, well, you can see there's an equal sign right there, right? And it's called the differential equation because you've got a derivative, a rate of change. See, it's saying that the instantaneous rate is 5% of the population per year. So years is our independent variable. We could pick whatever year we want. We want to study the population of some community, but they're saying that the population, the dependent variable, the y, right, is increasing at a particular rate. So it's like having dy dx. I know the variables over there are not y and x; they're p and t. Is equal to some constant right here. I'm gonna call it c for constant. Okay, like maybe like a c sub 1, a constant times y. So when a rate is directly proportional to its dependent variable, we have to separate the variables. We have to try to get the y with the dy, and we have to try to get the independent variable on the other side. Okay, so I like writing them as y's and x's because it might make it a little bit clearer. And so what they've done here is they move the independent or the dependent variable, the p variable, to the other side of the equation. Okay, I'll move that over just a little bit. So how would I do that if I had y's and x's here? I would divide by y. I would get 1 over y dy is equal to c sub 1 times dx. So now I've separated the variables, and that's what they did right here. That's what they did on this line. It's just that it's not y's and x's, right? Okay, well, what are we doing now? We're going to try to take the antiderivative of both sides because we want an equation. We don't want an equation with the rate. We want an equation for the population. So we want to try to get the p variable, isolated. We like it to be p equals. So they're saying, well, you can't take the antiderivative of 1 over p. Well, let's think about that for a second. If I was going to take the antiderivative of this, I know I've got a y here instead of a p, but that's the same as the antiderivative of y to the negative 1 dy. Why can't we do the power rule on this thing? Because when we raise the power by 1 and we divide by the new power, I would get y to the 0 divided by 0 if I tried the power rule. So you can't divide by 0, can't divide by 0, so you can't use the power rule. Can't divide by 0. All right. So that kind of answers that, explain why you cannot use the power rule on that. And then it says, well, let's set up a table and we'll try to evaluate it numerically. So I did that on Desmos and I attached that file for you. So if we look over here at Desmos, and you can see I've got the link and I copied it into your Google Classroom. And it wanted us to evaluate it at like 1,000. So you need to then type in a 2,000 on the next line, I think, because the next number they want us to do is 2,000, I think. Right? Let me see here. This is not letting me type another number in there. Uh-oh. I thought it would, no problem. Let me come over here, hit tab. Oh no. It's not doing it for me. 2,000. It might only let me do one number there because of the way I've set up my table, but I am really surprised it's doing that to me. So I'm just going to try to change this guy right here to a 2,000. Okay, so 2,000. Oh yeah, there we go. So it only lets me change it right up here because I said n is over here. That's unfortunate. I want to challenge you to try to make a table that would record all the values, like put a, maybe you put an x sub 1 here, and then you put an x sub, like n equals x sub 1 or something like that. I don't know. You see if you can get it to work. But here it is for 2,000. Let me switch back over to my problem. They wanted 1,000. Oh, 1,500 also. So you change this guy to 1,500. Boy, I thought that would work for sure when I set up my table. And then you record that, and then at 2000, we've already done the 2000, so let's do 2500. Let's do 3000. Okay, so 3000. And you're going to record all those, you know, in a table. Oh, I guess it didn't need to go 3000, but it does want 500 and 100. All right, so it says use these values to sketch the graph of the integral versus n. What kind of function has a graph of that shape? So what they're asking us to do is, you know, just put a graph of that thing down. So we graph this guy, and remember, like at 1000, if we put a little tick mark, let's say here, and we put 1000 in there. So let's do that. So on our graph, let's put 1000 right there, right? We had 0, didn't we? And then at 1500, let's say 1500's right here, 1500, I think it was just a little bit above that. And at 2000, it was a little bit higher than that, right? At 500, I think it's negative. Let's test that idea out real quick. Like where did this point come from right here? Well, back in my little table here, when I make this 500, I get negative 0.69 something. If I make it 100, I get negative 2.3. So I'm gonna graph that. So negative 100 would be, or excuse me, 100 would be like right here, and then negative 2.9 would be down here. And then if we did connect them together, what function does that look like? That's their question, right? What kind of function has that graph? Well, that is a logarithmic function. So I would write that down right down here on my problem number 1. It's a logarithmic function. Okay, that's what that is. That's what logarithmic functions look like. So like if I came back over here, you know, and I tried to convince you of that, y equals log of x. And then if I do a standard zoom here, you can see we got that shape. I know it gets real close to the y-axis there, but well, I hope I convinced you of that. That's what that shape is, logarithmic function. All right, hey, next one. Show that the integral on the right equals 0.5, which is between 2 of the values of the integral on the left that you found in problem number 1. Okay, so what was on the right side of our integral? Okay, let me look back here for a second here. Let's go back a page and see what that problem was all about. So on the right side, we're supposed to show that from 0 to 10, 0.5 dt. Okay, so let's see. Let's put that down. Okay, so what I'm saying is we've got 0 to 10, 0.5 dt. We're supposed to show that is equal to, I think it was 0.05, wasn't it? That equals 0.5. Yeah, it's 0.05 because it was a 5% rate of increase, right? So let's fix that real quick. This should be 0.05. Okay, so I can take the antiderivative of this guy. This guy is 0.05 t. I'm going to evaluate that from 0 to 10. This is what they want us to show. I plug in the 10 and I get 0.05. I plug in the 0 and I get 0. So it's definitely equal to 0.05. Now they want, dang it, Nelson. Let me try that again. That's definitely, when you multiply by 10, 0.5. So I get, right, because I take the 10 and I plug that in, 10 times 0.05, I get 0.5, right? So I definitely get 0.5 for my answer. Now it says show that it is equal to something in our table. Like, where is it here? It says which is between 2 of the values of the integral on the left. Okay, so let's see, where did we have 0.5? Was it like, oh, I keep forgetting, I got to change it up here. 2000? Oh, that's too much, right? Was 1500? So in between 1500 and 2000, right? So it wants us to use our solver to figure that out, okay? So let's think about how could I make that happen? Well, if I'm, that's gonna be tricky for us on Desmos, and we'll talk about that in class, like how to get Desmos to find, it's somewhere between 1500 and 2000, right? On a graphing calculator, we could set it up and it would do it on here. I'll show you how to do that in class, okay? So what we're saying is it's somewhere between 1500, somewhere between 1500 and 2000. That's where, you know, the integral of 1,000 to that n value of 1 over p dp is equal to 0.5. So the n needs to be somewhere between 1,500 and 2,000 to make that happen, right? And so we're going to look at how to get Desmos to find that answer for us. All right, number 3. How did we do number 3? The value of n in problem 2 is p of 10, the population of 10 years. Find p of 20, p of 0. Use these 3 points to sketch what you think the graph of p looks like. Okay, so this video is getting kind of lengthy. I'm going to pause it right here, and then we'll come back to it in video number 2. Thanks for watching video number 1.